All right, good morning, everybody. It's 11 in the morning. Happy Friday to everybody. Glad to be here. I'm Henry Meyer from Miami-Dade County Extension Office. It's a pleasure to be here with Mr. Robert Molleda for National Weather Service. We have an amazing webinar today. We're going to talk about the outlook of the 2023 Atlantic hurricane season. So remember, hurricane season started in June the 1st. So it's going to be a very interesting season, to say the least. So let me try to read something about Mr. Robert Molleda. He's the Warner Coordinator Meteorologist at the National Weather Service in Miami. He's a native of Miami. His interest in weather started when he was very young, with occasionally chilly winter cold fronts in Miami-Dade and the Hurricane David in the 1979. Robert received his bachelor's degree in atmospheric science from the Florida State University, and his career taking him through many of South Florida tropical cyclones, from the Category 5 Hurricane Andrew in 92 to the record-breaking in 2005 and 2020 hurricane season. He has worked in every aspect of hurricane forecasting, from assisting hurricane forecaster with data collection and to writing forecast, as well as conducting local national media interviews and briefing for governmental officials on expected hurricane storms. In 2005, Robert was elected as the Warning Coordinator Meteorologist for the Miami South Florida Forecaster Office. He's responsible for overseeing National Weather Service warning and impact decision support service program in South Florida, which involve frequent interaction with the Emergency Management Office and Public Safety Offices. He also leads the local National Weather Service public awareness and outreach program, and he's conducted many weather-related information and safety presentations to a wide range of community groups, including local, regional, and federal government, civil organization, business groups, and schools, and now here. Thank you very much, Robert, for being here. I know you're a busy guy over there, so thank you very much for doing this. Before doing a Robert presentation, I'm going to launch a pre-test, very easy, 4 questions. If you can take like a 1 minute, do it whatever you want, whatever you can. These are 4 easy or not so easy questions that we're going to have the same question at the end. Please make a sign if you can see it. All right, great. So take a few seconds, a few minutes to do this. This is going to help us measure if you are learning something today. We're going to have the same question at the end. All right, a couple of more seconds. All right, you can see the results. All right, so Robert, the floor is yours. We're going to have this. You're going to have the question at the end, and again, CUs. We have CUs for ISA, IF, and GLA. It's going to be at the end.
Oh, all right, Henry, thank you very much. Good morning, everyone. It's good to be back here again, virtually at least, to give a little presentation on hurricane season. Not just the outlook, of course, but also some of the things that we commonly see and use as information to help us prepare when hurricanes do threaten our area. And hopefully this year we won't be affected by hurricanes, but we know we're in a highly hurricane prone area, so we have to be ready just in case. All right, so I saw the answers to the questions, so that's good because we're gonna, Henry's gonna put them up again at the end, and we're gonna go through some of these things. So hopefully my presentation will help you to at least answer the questions. And I think actually I'll say this really quick. The questions, I think the answers were pretty good. So I don't know if we're gonna need if my presentation will be, I think my presentation hopefully will reinforce the answers, that you already provided. So anyway, so let's go ahead and move on. I'm going to share my screen. So 1 second here while I do that. Okay, so you should be seeing the title screen, preparing for 2023 hurricane season, making good decisions. And then I'm going to then move on here to the next slide. Okay, so we'll start out with the outlook for the hurricane season. Again, this is related to the first question. So the outlook for this hurricane season, which was released about 2 weeks ago, is calling for a little bit of an increased chance of what we call a near normal season. So in other words, number of storms that we're forecasting in the Atlantic Ocean this year from between now and November, or between the beginning of the season, June 1 and November 30th, is for anywhere from 12 to 17 named storms. Of those, 6 to 9 could become hurricanes. And then of those 6 to 9, between 1 and 4 major hurricanes. So that's leaning towards a near normal season. So what is normal? Well, so normal, I'm going to go to the next slide really quick here. Normal is 14 storms, 7 hurricanes, and 3 major hurricanes. So that's the normal based on a 30-year average of the number of storms that have formed in the Atlantic Ocean over the last 30 years. So if we go back to this slide, so put that, remember that's what we're relating it to. But there's also fairly high chances that it could be either below normal or above normal. Again, so the seasonal outlook for this year is a little bit more uncertain or less certain than normal based on, we have factors that are kind of competing with each other. So on the one hand, we have the El Nino pattern, which is a part of a global weather pattern or influences weather patterns worldwide. And one of the impacts of El Nino when that pattern is active, which it is already, for the Atlantic hurricane season is to reduce or lower the number of overall storms that can form. It doesn't mean that it eliminates storms or prevents storms from forming, just that it makes conditions less favorable for storms to form. So storms will still form, but it tends to limit or reduce that number. On the other hand, we have warmer than normal waters across most of the tropical Atlantic, and that favors or more storms to form. And then we also have other factors as well, such as the what we call the African easterly waves, or those tropical waves that move off the coast of Africa, especially during the peak of hurricane season. Those are expected to be a little bit more stronger or more active than normal. So we have competing factors. Which one is going to win out? That's what we don't know right now. That's why the forecast for the season is highly uncertain. Now, what I think, I'll say this: what we have in a typical season, and I don't think this year is going to be a lot different than most hurricane seasons, is we're going to have periods where you're going to have, not much going on. Like right now, there's no activity right now that we're looking at that we're concerned about in the tropics. And that's, fairly typical for this time of year, for the early part of the season. So there are going to be times where it's going to be pretty quiet, pretty inactive. But then we're going to have other times of the season where it's going to get more active, and typically in the Atlantic Ocean, the most active time of the year for hurricanes to form is August, September, and October. So during that time frame is when we typically see the most activity. So I don't think the season's going to be a lot different than that. We'll see what ends up happening. But So in other words, when we say near normal, that's really what we're talking about. We're not talking about, that any one part of the Atlantic is going to be more affected than another, or that we're not going to be affected. It's not really telling us any of that detail from a local perspective. It's more of a general, large scale, large area forecast. So these are the names of the storms. In fact, we already had one. We had a very small, weak tropical storm last week in the Gulf of Mexico. That was Arlene. So we've already gone through one. And those are the names for the remainder of the season here in the Atlantic Ocean. So let's go back to what I mentioned about what the average numbers are. So last year, so this map, this is what happened last year, 2022. So last year, the numbers, if you see there, those are the number of storms that actually formed last year compared to the normal or the average. Guess what? It was right on the average, very, very close to average. So you could say that 2022 was a near normal hurricane season, just like what we're forecasting 2023 to be. But if you ask the average Floridian who was around, in the 2022 hurricane season, was 2022 an average year for hurricanes? I think most people would say no, it was really busy. We had two hurricanes, Hurricane Ian, of course, was one of them. We had that tropical disturbance at the beginning of last hurricane season that dropped a lot of rain across South Florida. So the perception, and rightly so, would be no, 2022 was a bad hurricane season for Florida. But overall, it was near normal. So again, average is only a statistical indicator that's for a large area. It's not telling you one way or the other what areas may or may not be affected. So keep that in mind as we go into this hurricane season, what the seasonal outlook is saying and what it's not telling us. So the tropical weather, one of the changes that we've done for this year, we don't have a lot of new things or changes to the information that we provide. But I'll mention, one of these, which is right here, the tropical weather outlook, which is a daily forecast that the National Hurricane Center updates 4 times a day, which indicates areas where storms could be forming and what the potential formation chance is for those areas to form. Until this year, that forecast of possible formation extended out to 5 days in the future. Starting this year, we're extending it an extra 2 days. So now we're giving you a 7-day outlook of where storms might be forming and what the potential formation is for those areas. So this kind of reiterates what I mentioned before. The most active part of hurricane season typically is August to October. So inside that yellow box there, that's the time frame where typically hurricane season is most active. And that's the time frame, August, September, and October, where South Florida has been in the past affected the most or hit the most by not just tropical storms and hurricanes, but the strongest storms have hit us during that time frame. So at the end of the day, when it comes to, what our level of preparedness should be, what our expectation is for hurricane season, it should be the same every year because, we've been hit by hurricanes in active years. We've been hit by hurricanes in near normal years. And also we've been hit by hurricanes even in years that have been mostly below normal, like Hurricane Andrew in 1992, for example. So this is our hurricane history. So this is a map showing all the hurricanes that have tracked, that the center has passed within 50 miles of Miami. So basically storms that have affected Miami-Dade County in one form or another directly. Again, these are hurricanes only. These are not tropical storms, they're just hurricanes. So, we've been hit quite a bit. So that alone should be kind of, our guide or our motivator to be ready, because we don't know, we can't forecast with any level of specificity where hurricanes are going to form later in the season and where they're going to go. Those small weather systems that influence where hurricanes are going to form and go later in the season, we can't see those now. It's too far out in the future. So, hurricane season, we're ready now. We're ready at the beginning of the season, but it's about remaining ready. Just thinking of hurricane season as a marathon. Taking it steady, slow and steady. Make sure that we stay ready throughout the year, understanding there's going to be quiet periods and there's going to be active periods. Maintain, make sure you're updated with the forecasts. You're keeping track of what's going on, especially once we get to the most active part of the hurricane season, which again is August through October. Now, the good news is, and we continue to see improvements in the hurricane forecasts, both with the track of the storm, forecasting the track of the storm, and also forecasting the intensity or the strength of the storm. So we've made big improvements since the year 2000. So that's what these slides are showing. Those graphs are showing that we've made 64% improvement in the track of the storms over, let's say, over a 3-day period. So let's say if we compare the 3-day forecast to what occurred in that 3-day time frame, the track forecasts have improved by 64%, and the intensity forecast or the strength, that's improved by 50%. And that the intensity forecast was an area that we, for a long time, were struggling to make improvements on. But more recently, in the last 5 to 7 years, we've made some significant improvements, and you're seeing it there in those statistics. And a good example of that was last year. Last year, Hurricane Ian, as we know, that was the big storm of the year. That one formed down in the Caribbean Sea, and when it was down in the Caribbean, when it was starting to get organized and to get stronger, we were able to accurately forecast a rapid intensification of that storm from a 60-mile-an-hour tropical storm to a 100-mile-per-hour Category 2 hurricane in only 24 hours. So we forecast an increase of 40 miles an hour in the wind in only 24 hours. And that's exactly what happened with Hurricane Ian. Now, as we know from there, it increased even more later on as it got closer to Florida. So this is something that we need to be very mindful of, because Florida especially is in an area where historically storms have gained strength very rapidly in a short period of time. We have a lot of warm water around us, and other conditions also in the atmosphere sometimes line up so that we can have these rapidly intensifying hurricanes very close by. So of the 9, we've had these, this is a map of the 9 strongest hurricanes that have made landfall in the United States, going back, going back back in time. The most recent one was Hurricane Ian, which is on this list now as well. All of those 9, each of those 9 hurricanes were tropical storms only 3 days before landfall. So they went from tropical storms or less 3 days before to a Category 4, Category 5 hurricane. So that shows you where, why Florida is particularly prone to being hit or being affected by those rapidly intensifying hurricanes. So last year was another reminder that tropical storms bring multiple hazards. So yes, they bring a lot of wind. They also bring a lot of water, water flooding, right? In the form of storm surge, in the form of rainfall flooding, and also we get tornadoes associated with tropical systems. So last year, we started out the hurricane season last year with a tropical disturbance that didn't have a name, or it didn't get a name until it passed Florida. But when it moved up over Florida from the Gulf of Mexico, it brought a lot of rainfall. So again, a tropical disturbance didn't have a name, but it brought waves of rain across the South Florida region for like 2 or 3 days. And we ended up, in Miami-Dade County with areas of rainfall, like 8, 9, 10 inches of rain, even more in some areas. And actually, a few days after the storm passed Florida, we got an additional like 8, 9 inches of rain in the Cutler Bay area. So, there are areas of Miami-Dade County that had severe flooding for several days. And this wasn't even from a named storm. So it goes to show that we don't need a named storm. Any tropical system that has some type of organization, they bring a lot of rainfall, a lot of moisture into the area. So we have to be very mindful of that. Then, last year it got, we didn't have a lot of activity after those first couple of storms in June. But then when we got to August, as we said before, that's when conditions started to get more favorable for storms to form. And sure enough, that's what happened. In September, that continued. September is the peak of hurricane season. And towards the end of September, that's when Hurricane Ian formed down in the Caribbean. As we know, it tracked down in the Caribbean, then it started to move north, moved over the westernmost part of Cuba, and then made it into the Gulf of Mexico, moved over the southeast Gulf of Mexico, and made landfall in Southwest Florida as a Category 4 hurricane. So for Southeast Florida, our impacts, we did have impacts, but the most significant, the most severe impacts were over on the southwest coast of Florida, where, of course, we saw there was a huge storm surge. These are pictures of the storm surge coming into Fort Myers Beach, where we had 10 to 15 feet of water over ground. So in other words, when we say 10 to 15 feet of flooding, when we say 10 to 15 feet of storm surge, what we're really saying is that's how much water was over normally dry ground. So that's how deep the water was over ground that's normally dry. So that's, a lot of water, obviously, a lot of flooding. And, of course, we all know how bad, how bad it was there and the devastation that occurred, or that occurred as a result of that. Now, so we're going to talk a little bit more about storm surge here, but I do want to mention, though, with Hurricane Ian in Southeast Florida, the main impact wasn't so much the wind, it wasn't storm surge, but it was tornadoes. We actually had 13 total tornadoes that formed in the outer fringes, in the outer rain bands of the hurricane as the hurricane was still approaching. So these tornadoes occurred the day before the storm made landfall near Fort Myers. So that's something that we see a lot with hurricanes is, especially when they come from the Gulf of Mexico, from the Caribbean, and they move up over Florida, those tornadoes tend to occur in advance of the storm, like a day before, sometimes 2 days before. That's very common, and that's what we saw with Hurricane Ian. Most of the tornadoes occurred to the north of Miami-Dade County, like Broward and Palm Beach counties got most of those tornadoes, and you see some pictures of some of the damage caused by those tornadoes. So again, hurricanes bring, more than one type of hazard, and those hazards can be extended over a long period of time, not just the day of a landfall, but they can occur the day before, or even sometimes even 2 days before the storm makes landfall. And then in November, when the hurricane season typically starts to get to calm down towards the end of the hurricane season, we had a hurricane that formed, or a tropical storm that formed east of the Bahamas, moved westward, and it did become a hurricane right before it made landfall up in Vero Beach. So the impacts to South Florida were not much, but even with this storm, even though it made landfall farther to the north, we had a lot of high waves, very rough surf that affected the coastline of Southeast Florida and led to some damage. It damaged several piers, mainly up in Broward County and also in Palm Beach County. It also led to a lot of beach erosion. The beach got eroded significantly in some of those areas. And again, so storms sometimes that come in from the Atlantic bring a lot of high waves ahead of the storm. Even if the storm makes landfall farther north, we're still getting some of the waves, some of those very high dangerous waves from these distant hurricanes. Okay, so we talked about, the different hazards. So of course the wind gets a lot of attention, and for good reason. We should. The wind is very dangerous, and we protect our homes based on the wind potential. So understanding that the Saffir-Simpson scale, that's the scale that we use that relates to the wind of the storm. So when you hear, the category, let's say, we have a Category 1 hurricane or a Category 2 hurricane, that's referring to the wind. That's not referring to the other hazards and what level those are. There's other ways that we can determine that, which we'll talk about later. But remember, the Saffir-Simpson scale is a wind scale only, and it relates to the level of potential damage. So as you go up the scale from a 1, now a 1 is dangerous winds. A 1 has winds of at least 74 to as high as 95 miles per hour, which is damaging wind and dangerous wind. But as you go up the scale, the potential damage increases exponentially. So it doesn't go up in a steady way. It goes up in a very fast exponential. You look at a graph, the line doesn't go straight, it goes up like that. So from a 1 to a 5, the potential damage increases by 500 times, not by 5 times, 500 times. So, and you see how the difference is as you go up each category on that scale. But as we saw with Ian, and we've seen with many other storms in the past, it's the water that is the most dangerous part of the storm. It's the water that really kills the most people in landfalling hurricanes. 9 out of 10 people historically have died as a result of the water, whether it's storm surge or rainfall. Yes, people do die from the wind as well, but those numbers are relatively low compared to the other hazards, especially the water hazards. And if we look at the statistics from Hurricane Ian, so this graph shows the age ranges of the people that died as a result of Hurricane Ian in the state of Florida. So this is only for Florida. There were at least 141 fatalities that were at least directly or indirectly related to Ian. 66 of those were determined to be directly caused by the effects of the storm. And of those 66, at least 53 of those 66 were caused by water. Only 4 were related to the wind. So we can hide from the wind, right? We put shutters up, we protect our homes and our buildings, and we can hide and protect ourselves from the wind. But you can't do that with the water. So the common slogan that we use is you hide from the wind, but you run from the water, because the water gets into a building, no matter how well built that building is. Once water gets in, the building can get compromised. And not only that, but your life, you become at risk. Your life becomes at risk when water starts entering your home and you're there. So look at the age ranges of the people that died from Ian. The average age was 66.5 years of age for the people that died. Most of the deaths were 60 years of age or older. So, it's the most vulnerable populations, unfortunately, that always get affected the most by big weather systems like hurricanes. And most of these deaths, I don't have the exact numbers, but I know that most of these occurred in evacuation areas. So they were in areas where they were ordered to evacuate for one reason or another. We don't know all the reasons. People, they decided to stay. And unfortunately, some of those people died, which is sad. But, it's important that we always remember, and we're going to talk a little bit more about this now. Storm surge is particularly a very deadly part of the storm, and we have to take those evacuation orders seriously. So one of the questions that we asked, and you're going to see it again, so make sure you remember the answer. So what is the minimum storm surge depth, or how deep is the storm surge? What's the minimum depth of that storm surge that we consider to be life-threatening? At what level? So the answer actually is 3 feet. And I think, if I remember correctly, most everyone got that right. So that was, I think it was like 2/3 of the people got that answer correct, which is good. That's good. It doesn't have to be 10 feet. It doesn't have to be 15 feet for storm surge to be deadly, potentially deadly. As little as 3 feet. That's all it takes. And to give you an example of that, we have a pole in front of our building at the National Weather Service here in Miami that is broken down by color, and each color represents a range of water depth. So the bottom part, the blue one is from the ground up to 3 feet high. Then the yellow is from 3 to 6 feet. The orange is 6 to 9 feet, and the red is 9 to 12 feet. So the top of the pole is 12 feet above the ground. And so there's another picture there of me standing next to the pole to give you a little bit of perspective. So, so picture yourself and where you would be relative to that pole. And also consider that in Naples, there are 3 people that died that were, that died as a direct result of the storm surge. So the storm surge entered their home and they drowned. Indeed, the water depth in those areas was about 5 feet, 5 to 6 feet, no more than that. So 5 to 6 feet of water. Think about, how tall you are and how tall, let's see, for example, buildings and stuff, your house, things that you're familiar with. 5 to 6 feet is pretty high. So it doesn't have to be 10 or 15 feet. 5 to 6 is more than enough to be very, very dangerous. So that's why we consider 3 feet to be, that's the limit. Okay, from 3 feet up, that's life-threatening storm surge. And the evacuation zones, or in Miami-Dade County, they're called storm surge planning zones. Those zones are determined based on the potential or the vulnerability of that type of water entering, over land, that type of flooding over ground level. So the storm surge zones are there for a reason. They're there based on, they're determined by the elevation of the land, as well as the potential storm surge that could be brought in by hurricanes of different categories. So it's very important that you know and understand whether you live in one of these evacuation zones. Broward County has a similar, they have evacuation zones as well. So know whether you live and work in an evacuation zone, because if you do, the first thing you're gonna have to think about is, well, where am I gonna spend the storm? I may be ordered to evacuate. So when the storm is out there, we take the information from that storm, how big the storm is, how strong the storm is, which way the storm is moving. And then we run our storm surge model that then gives us an idea of how much storm surge flooding could occur in any part of those evacuation areas that we just looked at. And that's the information that we provide to the emergency managers and to the mayor, and they're the ones that make the decisions on what areas need to be evacuated and when, how far back before the storm, so that people have enough time to evacuate. So that needs to be first part of your plan. Do I live in an evacuation zone? Yes or no? If you do, well, then you need to think about, okay, where am I going to spend the storm? There's a chance I may have to leave. Okay, if you don't live in an evacuation zone, then the recommendation from our local officials is to shelter in place. In other words, stay home. If you're comfortable being at home and you have shutters up and you have all the things that you need as part of your plan, shelter in place. You may decide, what, I still don't want to be home. I don't feel comfortable. I don't feel safe for whatever reason. That's okay. You can go maybe to a relative or friend's house. Maybe you stay at a hotel that's outside the evacuation zone. You don't have to evacuate a long distance. Sometimes you can only have to evacuate maybe 10, 15 miles. As long as you get outside of the evacuation zones, you will be fine. And don't wait until the last minute. If you're going to leave town entirely, don't wait until the last minute. Don't wait until the day before even, because the roads are going to be full of cars leaving. And the chances of you being stranded when the storm comes are much higher if you wait until the last minute. Okay, so when we're looking at storm information, when there's storms out there and we start watching it, looking at it closely, there's a lot of different tools that we can use to help us determine what our threat is. And one of the most popular, I would say probably the most popular, is the forecast cone. So, the forecast shows the dots of where the forecast of the center of the storm is to be, the forecast of it. And then around those dots is a cone showing you, based on our average forecast error, based on what the average error has been over the last 5 years, that's the area where the center of the storm, statistically speaking, is more likely to end up or be. Anywhere inside that cone, there's about a 2 in 3 chance, or it's like a 67% chance that the center of the storm is going to be somewhere within that cone. Okay, that's fine. Let's assume that the center of the storm ends up inside the cone, right? Does that mean that if you're outside the cone, you're going to be okay? that nothing's going to happen? Absolutely not, because we see it with every storm, with every hurricane. The impacts extend outside the cone because the cone is only looking at the center of the storm. It's not taking into account how big the storm is, how wide it is. So we saw an example last year with this tropical disturbance that we had at the beginning of June last year that brought all that rain to our area. The edge of the cone is that black line that I drew on the right map, the map on the right. The cone never got down to Miami. The cone was always north of Miami. However, the rainfall, the highest rainfall threat, which is what that map is showing, was down in Miami-Dade and Broward counties, the red areas. So those red areas were outside the cone. But we got the most rainfall. We got the worst flooding from that storm, even though the storm tracked to our north. Why? Because again, impacts extend well outside the cone. The cone does not recognize how big the storm is. Another example was Hurricane Ian. Ian, well, from about 3 days before the storm made landfall to the time it made landfall, the cone never got south of Fort Myers. So Fort Myers was about as far south as the cone got. But as we saw in the example I showed earlier, in the Naples area, they had big storm surge, even that, all the way down to Naples, where the water got up to 8 to 10 feet. And so they were outside the cone, yet they had severe storm surge. So again, impacts from tropical storms extend well outside the cone. So again, the cone is determined based on the average forecast errors. It doesn't take into account how big the storm is. So the cone is the same size. The cone size does not change throughout the season. It stays the same for every storm. So the cone, because of that, does not tell you where the impacts of the storm are going to be, or where the impacts of the storm could end up going. We have other information that we provide that helps you with that, helps you answer that question and helps you with that information. So we're gonna talk about that here now. So, when we're planning and preparing, excuse me, when we're planning and preparing for a hurricane, right? We want to know some basic things, like, for example, when are the winds going to arrive? How strong will the winds be? How much rainfall? How much storm surge might my area get? So in other words, what's the threat to our local community, to my neighborhood, to my city? So to answer those questions, we have several pieces of information or graphics or products that we provide on our website, on the National Hurricane Center website, on the National Weather Service Miami website, that help to answer those questions. One of those is the wind speed probability maps. So these are maps that basically show for an area where the storm could potentially affect, what are the chances or the probability of either tropical storm force winds or hurricane force winds affecting that area. So it gives you a probability. And these wind speed probabilities take into account the size of the storm. So they do actually consider, they know how big the storm is. These graphics also take into account all the different models that we have. Everyone likes to look at the spaghetti maps, but remember, the official forecast that you see is based already on all those models. We don't need to show the spaghetti models on top of our forecast because it's already taking that into account. And these wind speed probability maps also take into account how different the different models are, or how similar they are. And it helps to refine the maps that you see here, the information, the probabilities that you see. So how this works is it takes the models into account, takes the size of the storm into account, and it also takes into account any shift in the forecast, any shift in the actual track of the storm. So we don't assume that the storm only has one potential track, that it's going to go exactly where we're forecasting it to. In reality, the storm could take many different tracks. It could go to the left of the forecast track. It could go to the right of the forecast track. We run a total of 1,000 realistic alternate scenarios. So not the forecast, but alternate scenarios. So based on all those alternate scenarios, we then calculate the ones which have the potential for bringing the worst conditions to your area. So that's how we provide the wind speed probabilities. And that's how we also provide to you the timing of the winds, which is another piece of information that's on the National Hurricane Center website. For each storm, we have maps to show you the wind speed probabilities. We have maps that also show you the arrival, the time of arrival of the tropical storm force winds associated with an incoming storm. And this is also based on those 1,000 alternate realistic scenarios. So the ones that bring the storm in quicker is what we use for the earliest reasonable time. So if you have preparations that take a long time to get ready, a long time to complete, and you want to make sure that those preparations are done before the winds arrive, then the time to use is the one on the left, the earliest reasonable time, because that's taking into account which of those scenarios bring the storm in the earliest. So the chances are it's going to arrive after this time. The odds are very much in your favor if you use this time. Now, if you have some preparations that you don't need a lot of time to do, that you can maybe wait until the storm gets close, then you could use the one on the right, which is the most likely time. That most likely map, that time is based on the actual forecast. So assuming that the forecast is going to be pretty close to being correct, or like really close, if you have that much faith in the forecast and you can assume a little bit of risk, then use the timing on the right. So sometimes a combination of the two is actually what works best. So we're giving you a range of different timing that you can use in your planning and in your preparation. So remember that, the forecast behind the scenes, the meteorologists, we're not just considering one potential, our forecast. We're also considering all those different realistic alternate scenarios in order for us to properly convey what your level of risk is. Because again, weather is not a perfect science. It can shift. Those changes or those shifts one way or the other can make a big difference in what we end up getting, in our area. It could be better if it goes farther from us, but if it ends up coming closer to us, then we end up having to then consider what is it going to be like, if the storm comes closer than forecast. And that's what we use when we produce these maps, these hurricane threat and impact maps. These are on our website, National Weather Service Miami website, weather.gov/Miami. They're done with every forecast that comes out from the Hurricane Center, so every 6 hours. And they're also put on social media. We make these widely available. So these maps tell you what to prepare for. In other words, what should we safely prepare for, just in case the storm takes the track closer to us. So in case we get what we call a reasonable worst case scenario, not the absolute worst case scenario, but a reasonable worst case scenario. In other words, it has a chance of happening actually. So they're broken down by different color levels, which indicate the level of threat. So yellow is a lower threat. As you go up the scale to orange and red, the threat gets higher and more dangerous. And then purple is the highest threat level. So we do that for the wind. We do that for the storm surge, for the flooding rainfall threat, and for the tornadoes. So each of the hazards are evaluated and assessed based on the forecast track, based on those 1,000 the range of possible scenarios. So these are really what to prepare for maps. It's likely that what we prepare for based on these maps is not going to happen. It'll be not as bad. That's more than likely what's going to happen, but not always. Not always. In fact, there are times where that's not going to happen. There's times where we are going to get exactly what that's depicting if the storm changes direction. Think about Fort Myers last year. Initially, the center of the storm was forecast to go farther north, maybe closer to Tampa. And Fort Myers was not expected to get as bad of conditions. But we were still depicting in the Fort Myers area the chance of, in fact, this storm surge map here shows we were depicting purple for storm surge, which is the highest, more severe level of storm surge, as what could potentially occur, what to prepare for in a reasonable worst case scenario. Well, unfortunately for Fort Myers, their reasonable worst case scenario ended up happening. So that's, again, a good reminder. That's what these maps are intended to do, is to prepare you properly so that we don't get caught underprepared, we don't get caught off guard, and by doing so, we can protect ourselves and our property and our families. That's what the bottom line here with this information that we provide. It's not just to exercise our science, it's actually to use our science, use the knowledge that we have and the tools that we have to help you make good decisions that are going to protect you, your family, and your home. So, very important. Watches and warnings are very important for us to receive and for us to take the action that is telling us to do. So the watch means that, for example, a hurricane watch, a storm surge watch, means that those conditions are possible within a 48-hour time frame. So that's when we need to start to make those initial preparations. If we go to a warning, then that means that the hurricane or a storm surge is expected to occur somewhere in that warning area within a 36-hour time frame. And these watches and warnings are not issued for just a one spot where the center of the storm is expected to make landfall. Those watches and warnings, as you know, if you've seen these before, they tend to cover pretty large areas. Why? Because, again, we are accounting for the range of possible scenarios. We're accounting for the realistic possibility that the storm could shift one way or the other. So we want to make sure that these watches and warnings are in the right place relative to where the storm could end up going. So at the end of the day, watches and warnings, those are our primary risk communication tools. Okay, this is what we want you to prepare for based on where the storm is, what the forecast is, what the range of potential scenarios are, and our level of expertise and confidence in our forecasts. So I think we know this here. We need to make sure that we're getting the information, storm information, watches, warnings, anything related to the storm from trusted local official sources. So that's the National Weather Service, of course, the local media, and also our local officials, our city, the county, state officials. We coordinate, we work closely together to communicate this information in between these groups so that we can then convey the same consistent information to you. So again, our website's a great resource, weather.gov/Miami. Hurricane Center's website, hurricanes.gov. And we also put this information on social media. Two more quick things before we wrap up. Very, very important that we keep in mind that the dangers from tropical storms and hurricanes also continue after the storm passes. We see a lot of injuries and deaths that occur not just during the storm, but after the storm. This is related to things like misusing generators, which can lead to carbon monoxide poisoning, vehicle accidents, because traffic lights aren't working, there's no power. The lack of power, also can lead to people suffering from heat exhaustion, heat illness. People touching down power lines, which are still live. So very, very important that we take care of ourselves and we take it very carefully and very slowly after the storm passes. We see too many injuries and too many fatalities after the storm. So when a storm is threatening, we need to make sure that we're getting the information, that we're using the latest forecast information. That we want to make sure that we don't anchor ourselves into a past forecast, that we think, okay, I like that forecast. Okay, the one that I saw yesterday, that forecast had the storm going north of me. I like that forecast. That's what I'm going to prepare based on. Well, maybe at that time, but as the forecast changes, and remember, as we're putting out watches and warnings and we're updating all these maps that we just showed, we're conveying what your level of threat really is, and it can change from forecast to forecast. So keep track of the latest forecasts. Don't anchor yourself to a past forecast. Don't anchor yourself to a perception that might not be really the reality. So we work around the clock. National Weather Service, we have forecasters working 24/7. Not the same person, obviously, but we have groups of forecasters. Our staff works rotating shifts so that you have the latest information to make those good decisions. As we said back at the beginning, hurricanes strike any year. It could be, maybe this year will be fine. Most years we don't get directly hit, but we don't know what years ahead of time. We don't know what year it's going to be our year to get hit. So we need to be ready any year. Doesn't matter what that seasonal forecast shows. We've been hit in all different types of seasons, active, inactive, and somewhere near normal, like what we're forecasting for this year. We need to take every storm seriously. Every storm presents different levels of hazards, as we saw. Tropical storms, tropical disturbances, and of course, hurricanes too. And not every storm is the same. Just because you went through a storm before doesn't mean that the next storm is going to be similar to that last one. It could be totally different. And in fact, it will likely be totally different than the last one that you experienced. So base your preparations off of that event, that specific event that's coming or that might come. Okay, so that's all I have as far as the slides. Henry, I'll take it. I'll give it back to you. How you want to proceed? I think we're going to put the questions up again, and I'll be happy to stick around if there's time for any individual questions from anyone out there.
Thank you, Robert. It's amazing. My brain is full, to say the least. Hey, let me check the questions here. Thank you, Barbara, for your link over there for the maps. I don't see many questions here, so if anybody of you guys has any comments, idea, feel free to post it in the chat, or if you want to talk, you can unmute yourself. Question for you, Robert. Can the hurricane happens outside the hurricane season? Can you have a hurricane maybe in January or February?
It can. It's very unusual. I would say, as far as hurricanes themselves, I would say it's pretty rare to have a hurricane, outside the hurricane season. Typically what we see outside the season is like tropical storms, like in May, for example, sometimes in April, even in December, sometimes we've seen tropical storms. It's not impossible that you can get a hurricane out there in the Atlantic outside the hurricane season, but it's very, very unusual. Like overall, if you count tropical storms and hurricanes both, it's about 90% of those fall or occur within the 6 months of the hurricane season.
Thank you. Any data for flooding forecast or nowcast?
I'm not sure exactly what's meant by that, but what I'll say is when we, as part of the hurricane, let's say as part of the forecasts that come out, that are updated every 6 hours with the hurricane, we provide forecast information on how much rainfall, might fall, as well as how much storm surge, and that's part of the information that we provide that goes into those maps that I showed. So yeah, we'll indicate, what there's a potential for example, 8 to 12 inches of rain across South Florida, or we'll say, there's the potential for storm surge that could be up to 3 to 5 feet above ground level. So that information is provided with every forecast, that especially when storms are close to or threatening South Florida. I'm saying, okay, yeah, I see the question is the occurrence shifting over years, earlier or later. We haven't really seen a big change, to be honest with you. It's, we've seen in the past where we do sometimes get tropical storms that will form like in May, maybe a couple of weeks before hurricane season, but still overall, like I said before, 90% of all tropical storms and hurricanes form during the June 1 to November 30th timeframe. So I don't think there's been a really big or important change in that. Okay, see 2 more questions. The El Nino outlook, the El Nino's already out there. So the El Nino event began and is expected to continue through the hurricane season. So again, as I mentioned at the beginning, El Nino, when it's present during hurricane season, does tend to perhaps limit or reduce the number of storms that could form in the Atlantic Ocean. However, we have other factors that are going the other direction that may lead to more storms to form, which is warmer waters and stronger tropical waves. Someone had a question about evacuation zones. I don't know if they're able to talk, but I think you can. If you can unmute yourself, if you have a question about evacuation zones, please go right ahead.
Yeah, yes, actually, this is just an experience last year with Ian in Kissimmee. There were areas that were severely flooded, and that was like the first time ever. So I know you were mentioning like if you are in an evacuation zone to try to seek shelter or go out of the area. But what about these people that are in places where in that map it doesn't show they will flood and they still do? That will be like who could be who to contact or what can what would you suggest? And thank you.
Oh, yeah, you're welcome. The evacuation zones are based on storm surge. Okay, those the ones that I mentioned. Now, there are also flood zones that include that are for rainfall flooding for inland areas as well. So those are not the ones that are shown in the evacuation zones. Now, there will be times if there's a lot of rain, like what happened with Ian in Central Florida, that the local officials will determine, look, we need to evacuate some areas because they're getting too much rain and there's too much flooding. So that's done separately from storm surge. So for that, definitely make sure that you are aware of what that area does, the county or the city does, as far as potential evacuations for rainfall flooding, and to make sure that you're getting that information. When they're ordering evacuations for rainfall from a lot of rain, that that people pay attention to that. Yeah, but that's separate from the storm surge evacuation zones.
All right, so let me post the post survey and lunch. So you can take we have a few minutes to end this webinar. So please take 1 minute to finish. Everybody learning a lot here. The pre-post was very on target, so I guess you did a very good job, Robert.
No, I think people, people already have a lot of, they understand a lot of this already. So I think, that's the answers that we got before I even said a word. we're on the right side,
Right.
So yeah.
And Vincent is right. I mean, despite the forecast, maybe only one. It takes only one.
Yep, exactly.
All right, guys, let me finish with this. Let me stop this.
Oh, that's so cute.
All right. So, yep, you can see the questions over there. Do you want to go ahead and check the answer, Robert, or?
Yeah, no, I mean, it looks like, the majority, the number, the percentage increased more towards the correct answer. The one that stayed about the same was the second one about the amount of rainfall that we can get from a tropical system. The amount of rain we can get from a tropical system does not depend on how strong the winds are. In fact, I gave the example of the tropical disturbance last year. The winds with that tropical disturbance were like 30 miles an hour. Yet we had 10, 15 inches of rainfall in in Miami-Dade County. So no, the number two, there's the amount of rainfall does not depend on how strong the winds are. We can have very low winds and a lot of rainfall. So that one's definitely false. Well, that one is, the correct answer is false.
Great. All right, guys, it's noon, it's lunchtime. Thank you very much, Robert. I mean, that's a great webinar. I'm going to post a link for the recording. so everybody can watch it and refresh some type of knowledge. ISA, CUs, FNGLA will be emailed to you guys whenever you need it. And please complete the survey. When you finish this, you're going to receive a survey. Please complete the survey. This is important for us. So thank you again, everybody. Happy weekend and happy hurricane season for everybody. Thank you,
Yes,
Robert.
thank you very much. Thank you. Thank you, Henry. Thanks, everyone. Take care.